And here we have it, another plexiglass LED sign that was 3D printed and programmed with an ATtiny85, which runs off of 3 AA batteries. In my previous version from 2018, I created the foundation from wood instead of 3D printed material, and powered the LEDs with a 12-volt adapter instead of batteries. In the new version, we have no external cords, so it is portable and sharp looking. It also features over 20 different color functions instead of one solid color. To start off, we have the 3D printed parts starting with the motherboard enclosure. This holds the programmable ATtiny85 and any extra wires. At the back, there are 2 holes for the positive and negative wires coming from the batteries to power the components. The next gap near the front will allow the 3 wires from the ATtiny to power and control the LEDs that will sit on top of the enclosure. Next, we have the battery pack. There is a switch at the front that allows around 2 amps of current to flow through to give the components 4.5 volts to operate. The batteries are in series to boost the voltage from a standard 1.5 volt AA battery to 4.5 volts. There are 2 holes exiting the enclosure for the positive and negative wires. There are 4 screw holes that allow a lid to screw on flush with the battery pack to secure the batteries. Now we have a plate that sits on top of the battery pack and the wired base. As well as helping secure the glued parts together, this thin piece also acts as a guide and centers the 12 WS2812B LEDs in the middle for the plexiglass to sit on. Finally, the top of the project holds the plexiglass in place directly in the middle of the LED strip for maximum brightness. It also has a hole for the button to change the colors. Here I showcase what the final project looks like if all of the components were set together. I had a problem with warping around the corners of one of my pieces, so I had to reprint that. Surprisingly, it was caused from my fireplace being turned on and making my spare room cold where the printer is located. In the battery pack, I glued the metal plates to the enclosure using hot glue. Throughout the project, I also hot glued wires and solder joints down to secure them. Soldering the wires took a while because of pre-tinning each component, stripping all of the wires, and fitting the wires between the small gaps. Make sure to have proper ventilation and to not breathe in the fumes. I had a fan blowing so the fumes would dissipate. Having 2 pairs of metal helping hands helped improve the solder joints instead of my shaky hands holding them. Another challenge I had was the tight workspace. These wires had to fit in a small space, and if I messed up, I had to cut another wire and resolder. One tip I recommend when cutting wires is to give yourself extra room, then snip the remaining when the wires are in place. I had to solder the ATtiny85 according to this layout. The ground wire was soldered on the left of the ATtiny on pin 4. From pin 4, there were 2 other wires. One went to the ground of the LED strip, and the other went to one side of the momentary push button. Then from the other side of the push button, a wire went to pin 5, which is the bottom right side of the ATtiny85. Pin 6 was used to control the LED signal, and the top right pin had 5 volts to power the controller, as well as a wire leading to the LEDs to power the strip. The button was used as an input pull-up in the code, so it can receive and pass through a ground signal when pressed. As I make finishing touches, I connect and solder the wires to the LED strip for testing to ensure everything works and no fires. I make sure to test my components after each step when they receive power and ground. This helps figure out what may have caused a problem if one occurs, and I can easily backtrack. When gluing the 3D printed parts together, I use a glue called E6000, which dries pretty fast, and I have great luck using the other glue for projects. I use many different types of clamps to guarantee a strong bond between the parts. It's important not to clamp the project too hard, or that the pieces don't move out of place. When I had the clamp set, I made sure the project was still running. Before we get more into it, I want to show you guys my website, neha.com, where you can find links to all of my projects, ranging from coding programs to building sound systems, and get the most updated code and downloadable files. Here, you can also find other DIY projects that you can do at home. Now for my favorite part, carving the plexiglass. I first photoshopped an image, then printed the image out. I wanted to make sure that the picture was a good size for the frame and that the image was proportional to the plexiglass that I cut out. Afterward, I taped the image on the back to sketch out. When carving out the picture, the best tool to use is a Dremel or any small rotary tool. For the tip, I used a small, thin tip to follow the precise lines. It was hard to follow the lines in general, so I improvised and did the best I could. This happens because of the thickness of the plexiglass being a distance away from the actual picture. Depending on the rotation of the tip is hard to control and skips around the glass. I found that going with the rotation of the device is the best way to avoid slipping. In the middle of the flower, I shaded the middle and dug holes to represent the flower seeds of the anemone flower. I like to add different styles of shading because it shows up differently under the light and adds more of a 3D effect. For shading, I used a larger diameter tip to cover more area. I also used this tip when creating and shading the letters and drawing the stems. This could be a tedious process and could take some time depending on picture detail. I placed down an LED lamp which allowed me to see the project much better and allowed me to follow the lines more accurately. This project is universal. The plexiglass can easily be swapped, so you can create multiple sketches with different pieces of plexiglass for the one 3D printed stand. The etching process took around 2 hours for me to complete. Printing the materials will take around 5 hours for each sketch, which will total to around 20 hours of print time. Finally, the wiring process took about 2 hours to solder and test the code. I will link a video explaining how to upload to the ATtiny85 for those who are unfamiliar. However, an Arduino Nano will also fit sideways in the enclosure without much room to work for another option. I hope you enjoyed this project. Let me know if you created this project or what your thoughts were on this. Also, if you have any comments, questions, or other ideas, let me know in the comments below. Don't forget to subscribe and stay updated with new and innovative DIY projects. Thanks for watching, and I'll see you in the next one.